In this lesson, we're going to be looking at the idea of solving quadratic equations. Now, this concept is actually one that we've addressed a number of times throughout the lessons that we've done so far. So you're going to see a number of things that should be already familiar to you. When we talk about solving quadratic equations this way, this is kind of a general technique, a general approach to this. So a quick refresher, solving equations, that's something you can do. It doesn't have to be a quadratic equation. You can solve any equation. And the general rule is you're trying to find the values of the variable or the variables that satisfy the equation, that make the equation true. So we've done this before. We can find something called the solution. Since we introduced quadratics, I've introduced this other term called root. And as soon as we start talking about the root, we've also referred to that as the zeros. So finding the zeros was finding the roots. So we've already done this. And that, of course, is the same as the x-intercepts. So whenever we have found either of these, we've already had the concept of solving a quadratic equation. And that's what I'm going to start with here. If you take a look at this quadratic equation, this is the same as if we started with y equals x squared minus 12x plus 32. And how do you find the zeros of this? You set y equal to 0. And if I were to do that here, I would get 0 equals x squared minus 12x plus 32. So to find the zeros, we set y equal to 0. So this y value becomes 0. And as you can see, this is what I'm now referring to as a quadratic equation for me to solve. How would we have done this one? What we would have done is, let me just clear some space here, we would do SPI, or some variation of that. I'm going to use SPI to do what's known as decomposition. My sum is negative 12. My product is 1 times 32, which is 32. And my two numbers are going to be negative 4 and negative 8. So my decomposition is going to be x squared minus 4x minus 8x plus 32 equals 0. Negative 4x minus 8x is negative 12x. When I factor these first two terms by grouping, I take out a common factor of x and I end up with x minus 4. I bring down the negative sign, and then between 8x and 32, I can take out a common factor of 8, and I end up again with x minus 4. Now I have a common factor of x minus 4, and what's left is the factor x minus 8 equals 0. I've got something times something else. I have a factor times another factor equal to 0. Well, the only way for that to happen is for one of those factors to be equal to 0. So x minus 4 must be equal to 0, giving me x equals 4. X minus 8 must be equal to 0, giving me x minus 8. So my answer is x equals 4 or x equals 8. That is my solution. And in this case, you can see to solve an equation, find a value or values. So here we have two values. If we wanted to check this, how can we check x equals 4? We've done this before when we looked at linear systems. It's a left side, right side check. So the left side of this equation is x squared minus 12x plus 32. And I plug in x equals 4, so that becomes 4 squared minus 12 times 4 plus 32. That gives me 16 minus 48 plus 32, which is equal to 0. The right side of this equation was already 0, so left side equals right side, and that means this solution, x equals 4, is correct. If we did x equals 8, we would actually find out that it's also going to give me a left side of 0. So both of these solutions are correct. So if you've ever solved for a 0 of a quadratic by factoring, then you have solved a quadratic equation. Okay, let's take a look at another example. In this case, I've asked to say solve for y equals 0 or y equals 12. So let's start over here for y equals 0. So I'm going to then write my equation 0 equals 2x squared plus 5x minus 12. My sum, product, and integers for this one, my sum is going to be 5. My product is 2 times negative 12, that's negative 24. And my integers are going to be positive 8 and negative 3. So I get 0 equals 2x squared plus 5x gets broken up into plus 8x minus 3x minus 12. So we do decomposition now. Sorry, we just did decomposition. We do factoring by grouping. Between 2 and 8, common factor is 2. Between x squared and x, common factor is x. And that leaves another factor of x plus 4. I bring down the negative sign here, and there's a common factor of 3. So that leaves an x, and that's going to be plus 4. So 0 equals, we've got a common factor of x plus 4 and 2x minus 3. And now we can solve this. Now that we have factored form, we get x plus 4 equals 0 or 2x minus 3 equals 0. This one gives me x equals negative 4. This one gives me 2x equals 3 or x equals 3 over 2. For b, we want to solve for y equals negative 12. Now, what is the significance of negative 12? Well, there's already a negative 12 in this equation. And as it turns out, that negative 12 is actually the y-intercept. So the y-intercept is at the point 0, negative 12. In a previous lesson, I talked about the idea of symmetry. So if the y-intercept is at 0, negative 12, then sometimes we're interested in what's known as a matching point, which is at some other value of x, but the y value is also negative 12. We're going to be solving this equation for that matching point. It's just going to look a little bit different. So this is, as I mentioned at the beginning, this is just the more generic or more general way to do this. So let's go ahead and substitute in negative 12. So the left side becomes negative 12. The right side is 2x squared plus 5x minus 12. Now the thing that's different here is I don't want negative 12. Whenever we solve by factoring, it's always a factor times a factor equals 0. And I need the same thing here. So what I'm going to do is I'm actually going to add 12 to this side, and I want to turn this into 0, which means I have to add 12 over here. So I end up with 0 on the left side. So long as one of the sides is 0, you're fine. And on the right side, I end up with 2x squared plus 5x. This negative 12 added 12 also became 0. This is actually very simple to factor because this is just a common factoring exercise now. 2x plus 5. And how can this times this be equal to 0? That can occur if x equals 0 or if 2x plus 5 equals 0, which means 2x equals negative 5, x equals negative 5 over 2. So there are my two solutions for that one. When we did this before, when we did partial factoring, we started with the equation. Let me just change colors here. We started with y equals 2x squared plus 5x minus 12. And we still identified this value as 0, negative 12. And we still asked the question, what other value gives negative 12? But the way that we did it looked a little different. What we did was we did partial factoring. And so we took out the x, 2x plus 5 minus 12. And then we asked ourselves the question, what values of x will cause this whole thing to be negative 12? Well, those are the values that would cause this piece to be equal to 0. Well, that's what we did right here. Equal to 0. Just that piece equal to 0. So it's really the same kind of process. It's certainly the same kind of thinking. And so what makes this equal to 0? We get x equals 0, or we get 2x plus 5 equal to 0, x equals negative 5 over 2, which is exactly what we had here. So this one was finding when y is equal to 0 or when y is equal to negative 12. So let's take a look at a more visual representation of that. Here is the graph of 2x squared plus 5x minus 12. That's the black line, the parabola here. In red, I've drawn y equals 0. Well, y equals 0 is a horizontal line at the height of 0. The y value is 0. So essentially that's the x-axis. So when you are solving this equation for y equals 0, you are finding when does this parabola cross the x-axis, or when does it cross the line y equals 0. That's what it means to find the zeros. When we did this other one, y equals negative 12, we were imagining a line at y equals negative 12, and we were asking the question, where does this parabola cross the line y equals 12? And specifically, it's asking for what x values. Remember, we solved for different x values. So what did we end up solving for? In the case of the zeros, we found zeros at negative 4 and 3 over 2, which is the same as 1.5. Negative 4 and 3 over 2, which is the same as 1.5. So that's the same as 3 over 2. When we solved for the other value, negative 12, we ended up with an answer of 0 and negative 5 over 2. 0, that's the y-intercept, and negative 5 over 2, which is the same as negative 2.5. So that's another way to think about this. You've got your parabola, and then when you choose to solve for a particular y value, you're basically saying, where does this parabola cross that y value? So the general technique that we want to follow here is expand all terms, because the idea is we want to start from something in standard form, but we want that standard form to all be on one side of the equal sign. So if you, by very good luck, if you happen to be given the equation already in factored form with all the terms on one side already, then you might still have to expand out those brackets because you might have a number on the other side. So we have to make sure we move everything to one side of the equal sign, and only when everything's on one side of the equal sign, then we want to move it into factored form. So then we would factor our expression and then set each factor equal to 0 and solve. So here's something that looks a little bit more complicated. So we're going to expand all terms. So the left side just stays the same. The right side becomes negative x times 2x is negative 2x squared. And negative x times positive 13 is negative 13x. Now I'm going to make a little change here. I want to be mindful of this. When you're solving equations, it's actually, the convention is that your equal signs will run vertically down a single vertical column. So try to keep that in mind. I'm not expecting you to do a lot of erasing and redrawing your equations. So your equal signs might meander a little bit, and that's okay. But what you want to avoid is having your equal signs making dramatic changes in where they're located. Okay, so now we want to move everything to the same side. I think I'm going to move everything to the left side because that will make my x squared term, they'll all be positive. So I'm going to move everything over to the left. I add 2x squared. This negative 2x squared becomes positive 2x squared. So x squared plus 2x squared becomes 3x squared. Negative 13x comes over here, becomes positive 13x. And negative 10 just stays where it is. And that is equal to 0. Because I've moved everything from this right side over to the left. And see how my equal signs, they're not perfectly lined up. I can actually cheat a bit thanks to technology, so I can actually move that over, but obviously you're not going to have that option if you're doing pencil and paper. So just do your best. Okay, so now I want to factor this. I've done step 1, I've done step 2. Now I want to factor. The first kind of factoring we always do is we always start with common factoring. That's always step 1, but there are no common factors here. I look for special patterns. It's not perfect squares, so no special patterns. So now I go into my factoring by decomposition, which we give the acronym SPI, which gives us a sum. 3 times -10 gives me my product, and my two integers are 15 and -2. So now I write this. Since I'm going to be splitting this 13x, I'm going to actually move a little further to the left here to make even more room. So I can write plus 15x minus 2x minus 10 equals 0. So I made a little bit of extra room because I knew I was going from 3 terms to 4 terms. Common factor out of these first 2 terms is a 3x, leaving me an x plus 5. I bring down the negative sign here, and then between 2 and 10 there's the number 2. There's no common factor in the x's, so everything is left behind, which is an x plus 5 equals 0. We have an x plus 5, which is now common, and 3x minus 2 is the other factor. Something times something equals 0. How is that possible? That could occur if x plus 5 were equal to 0, or it could occur if 3x minus 2 were equal to 0. So I solve each of these little mini equations. It gives me x equals -5, or 3x equals 2, x equals 2/3. And just to remind you, 2/3 is the same as 0.667 approximately. And I just say that because of the graph we're about to look at on the next page. So this is the solution. These are the two values of x that make this equation true. Now let's think about this equation. I talked about you could look at the picture of things, so let's look at the picture involved here. Here is the left side of the equation, y equals x squared minus 10. This is a parabola, opens up, has a y-intercept at -10. Here's the second equation, y equals -x times 2x plus 13. This might be a harder one to figure out, but if you take a look, we've got a 0 here at 0. We have another 0 at -13/2, which is -6.5, which is about there, so that's correct. It is -x times positive 2x squared, so overall that's going to be a -2x squared, so it opens down. So this is our parabola. But if I'm setting these two things equal to each other in the equation, what am I doing? I'm asking, just in the same way that we were talking about where does a parabola cross a straight horizontal line, we could solve for that. Well, now I'm actually solving for where does this curve intersect this curve. And you can see in this case it intersects at 2 different locations. One of them is -5. That's one of the answers we got. One is positive 0.67, or positive 2/3. That's the other answer we got. And notice that the answers we got were the x values. So down here at -5, up here at 2/3. If we want those y values, we have to sub these x values into either equation in order to find that. Okay, so that's it for solving quadratic equations. As I mentioned at the beginning, this is something that you have done already. There's nothing really new here. This is just a more general way of approaching it.